It's preparing. It's being, all right, got it.
Says it is.
Yeah, this doesn't, every time, as I say, when I have a problem, it's a brand new problem that I never had before. Okay, we're all right now. Okay. We're all right.
Okay, it
Okay.
says live now.
Okay, very good. And so we're live now, and I will introduce you all in 1 second here. Here we go. Okay. Hi, I'm Metta Spencer. Today, let's talk some more about soil amendments, because there's a real chance that we can make a difference in the quality of our food and in the amount of food that we produce and in the healthiness of the environment when we don't poison it with chemical fertilizers. And we can even reduce climate change by using the right kind of rocks. If we put rocks on our soil, all pulverized, we can make a lot of improvement in this world. So it's worth talking about, and we've had some conversations already. But today I have 3 new experts, or they're not all new to me because I've seen one before several times, but 2 experts that I'm getting acquainted with today. Dr. Tom Gaureau is in Cambridge, Massachusetts. He is the president of the Global Coral Reef Alliance, which is a nonprofit organization for coral reef protection and sustainable management, and is the coordinator of the United Nations Commission on Sustainable Development Partnership in New Technologies for Small Island Developing States. What a mouthful, that's one word. He's also co-author of Geotherapy, which is really relevant to us today because although I really would like to talk to him about coral reefs, we're going to talk mostly about rock nests today as soil amendments. So now in Massachusetts is Joanna Campe, who's the executive director of Remineralize the Earth. She's an NGO addressing enhanced weathering for carbon removal. That's the code word for rock nest. And in Vermont, in Bridgeport, Vermont, is Thomas Vanacore. He's the founder and owner of Rock Nest Local in Vermont, and he's an expert on quarrying stone. So I've called upon him several times because everybody I mention as an interviewee already knows Tom and says he's the man to talk to. So I've already invited him a couple of times before, and it's good to have him back. Now, we also have 2 members of the Canadian Pugwash Group with us. Ellen Judd, who is a retired professor of anthropology, University of Manitoba, is, I think, in Winnipeg. And here, closer to home, for me, is Adele Buckley, who is a physicist and engineer, and a very important key member of the Canadian Pugwash Group for many years. She's carried the heavy lifting. So good morning, everybody. It's nice to see you all. So I'm going to start off with Tom Gaureau, because we were already into a good conversation. And let me start off by asking the connections among the various research projects that you carry on, because I know your chief focus has to do with coral reefs, which is one of our interests too, because we're interested in the technology of brightening clouds as a way of cooling the water in the ocean. And some people are trying that in the Australian Great Barrier Reef. But you also are an expert on enhanced weathering of rock. Can you explain any connection between these particular interests, and how do they overlap? And do you is there any reason that one line of investigation is combined with the other? Tom, you're muted. Yeah.
Excuse me. Yes, sorry. The common thread between what I do in these very different habitats is we're trying to look at how to regenerate severely damaged ecosystems in the most efficient way. And because every place we go in the coastal zone, they're dying. I mean, it's really tragic to see, especially if you've been diving as long as I have. But on land, the same thing. We see the destruction going on. And essentially, if we don't figure out how to regenerate all our ecosystems very quickly, we're going to be in deep trouble with global warming, because that's one of the major mechanisms we can use to remove CO2 is enhance the natural mechanisms that we've been destroying. So my common thread is trying to find ways to enhance the growth of ecosystems. So with regard to soil, I studied biogeochemistry, and really our interest is in understanding what makes plants fertile. There are some 20 elements that all life needs. You have to have it if you want to be healthy. If you don't, you're severely deficient. 20 different elements. And we're used to thinking plants just grow off air and water, but in fact, they get hydrogen, carbon, oxygen, and nitrogen from those, but everything else, all those other essential elements come from the ground, from the soil. They come from the minerals in the ground that are releasing those elements slowly from the rock phase. So that's where that limits the growth of plants. Most places we go, the plants are limited by some deficiency or another. And what we do with chemical fertilizers, we just dump nitrogen, phosphorus, and potassium on them. And all the other elements that they need are missing. So the result is they can't take up the elements they need because they're lacking the other essential elements. So we've been looking into really using rock powder and biochar as natural mechanisms of regenerating entire ecosystems. So that's how my interest came about.
Mm-hmm. So you've also looked at biochar, which I've been enthusiastic about for a long time. The combination seems, is there merit in combining them?
Well, I'm not sure if you want to introduce the others, but I'd like to show 4 quick images just to relate to this. If I can do it now, or I can do it later.
Go ahead.
Okay.
We'll introduce other people later.
Let me just, I think this, of course, Tom and John are going to add a lot more. Let me go to this. Okay, sorry. Well, first of all, basalt is the rock powder that's most useful. You can see it's found all over the world. Sorry, can you see my screen?
No.
You can't. Okay, so now I have to share screen. Okay, 1 second. And now I go to, share. And I think, can you see it now?
Yeah. Mm-hmm.
This is a global map of basalt. Now, the thing is, there are many different kinds of rocks. Each place has a different rock underneath because of its different geological history and how humans have used it. So each place has different spectrum of missing elements. But basalt is the one that has most of them in the most balanced level. Certain kinds of rocks are rich in one element, but missing in others and so forth. So basalt is really one of the best. It's extremely widespread in the world. So that's one reason why we focus on the use of it. Now, I did some experiments in Panama with basalt powder. And what we did is we simply grew trees for 5 years, hundreds of trees in local soil that was extremely impoverished and in rock dust from a basalt quarry. And what you can see here is the trees grew nearly 7 times faster in the rock dust and in the local soil. And it was enriched in all these elements that we analyzed, phosphorus, iron, all these essential elements pretty much were enriched. So we didn't measure all 20 of them, but you can see what happens. So basically by remineralizing the soil and adding the minerals that are missing, we can provide tremendous growth. Here's rock powder alone. We didn't add biochar, and biochar is also important because biochar is like charcoal. It's any form of carbon, you burn it without oxygen, you make a char. Some is low quality, some is high quality, depends what you make it from and what the temperature and pressure and how long you do it and all that. So there's a huge difference. People are calling very different materials biochar, but there's a huge range of properties. But the point is, the raw biochar, and you see it in red, actually inhibits the growth of pea seedlings.
Oh.
Mature biochar, which is biochar that's been aged with compost and rock powder, in blue, stimulates the growth. And that's because biochar isn't a fertilizer itself. What it does is it holds on to nutrients and holds on to water and makes them available to the fungi that feed the roots. So if you mix the two of them together and use mature biochar with rock powder, you get tremendous benefits. So that means that they should always be used together. And that's one problem we have in the field. People regard them as different activities. Here's another fun figure here. Joanna and I did some projects where we added biochar and basalt powder to different farm fields here. And one day I came and I counted the earthworm casts. This is earthworm excrement sitting on top of the soil. Now, I was led to this by Charles Darwin, whose last book is on the subject, by the way, on earthworms. So anyway, he crawled around counting earthworm castings. So I did the same. And what happened is with the basalt powder, we got huge increases in earthworm activity. Not much with biochar. Anywhere huge increase from 80 to nearly 100 times greater density. So feeding the soil with the right elements doesn't just feed the plants, it feeds the whole network of recirculating biochemical and biological systems in the soil that we also need to enhance, to maintain the recycling. We're killing that with commercial agriculture because what we're doing is adding poisons to stop the recycling. So if we do this, we get enormous benefits. I think that's it for figures. I just wanted to show you those, and let me now stop sharing the screen.
Oh, okay. That's fascinating. Absolutely wonderful.
Now,
but it's a little side off question, but one of my other interviewees who's interested, she's a forester, and she said that earthworms are not indigenous to Canada, or I don't know where else.
Yes,
but
that's right. They're brought in from Europe. Yes.
And she treats them as an alien species. And I don't know whether that's, I had always been told that earthworms are we should love them.
Yes. Well, the thing is that they died in Canada during the ice ages. It just got too cold for them. And they weren't able, when it cooled, warmed up again, they basically reintroduced exotic species from Europe that came in with the seeds in the soil. So exotic species are every place. And in some places, we're getting disastrous consequences. So anyway,
you're doing fine. I just
good luck. Yeah, but in some cases they can be benign or beneficial. So it's a mixed bag, and native species can be harmful as well. So
Oh, okay. Well, I won't worry about them then. It's good to know what they do.
Depends.
Okay, very fine. Fine. Well, now I want to say hello to Joanna. And you know each other, so you must have worked together in some way. Tell me, Joanna, what your project is. Your Remineralize the Earth is an NGO, I believe, trying to persuade us all to use some of the techniques that Tom has already been discussing. Is that right?
That's right. That's right. Remineralize the Earth has been an organization since 1996. I started a long time ago, actually, in the 1980s. I went based on the work of a book called The Survival of Civilization by John Helmicker and Don Weaver. So this was something that I read, felt was very important, wanted to make a difference around. Then I went down to the CO2 hearings of Senator Albert Gore in 1986. So then I, went to a climate conference where actually the scientists just laughed at the idea of using rock dust and soils. They just said, it's all silica. And they were chemistry-based scientists. So now, scientists are much more for agriculture, biological management as well. So that makes a tremendous difference. But we advocate remineralization, and there are actually slight difference and overlap between remineralization and enhanced weathering. So I think remineralization, to keep it very simple, we know to compost. Compost is like a household word. We know that we have to return the organic matter to the soils. Well, we're saying the same thing. How are soils formed? They're formed over millennia by glaciation, by volcanic eruptions and alluvial deposits. So rocks are the most abundant resource on Earth, one of the most abundant resources. So this is the way soils are formed. So it's a very extremely natural process. Not only do we need to recycle the organic matter, we also need to recycle the mineral nutrients. And especially today, because with industrial agriculture, all the minerals and trace elements of importance, and it's really up to 70 minerals and trace elements, have been, depleted in our soils. So the foods we eat are lacking in those minerals, which tremendously affects our health. So it's extremely important to be able to grow nutrient-dense food, and applying rock dust, organic matter, rock dust with all different kinds of biological techniques. Rock dust goes along with everything, whether it's compost, permaculture. It's you could say we've going from organic to sustainable to regenerative agriculture.
Mhm.
So it's really a key of regenerative agriculture.
Okay, well, I heard there's a sort of a meme that I've read saying that there's about 60 more generations of nutrients in the soil. And when we've raised 60 more crops, we will have used up the world's supply of minerals and nutrients. And therefore, we better start turning things around and start not only conserving the soil and keeping it from eroding and blowing away, but also restoring it, re-nourishing the soil, with replenishing it with materials and so on. So I presume that is something you became aware of long before the rest of us. I'm only gradually becoming aware that they say that you can eat carrots pulled from one kind of soil and eat the same looking carrot from a different field, and the quality of your food is entirely different. Is that the case? And is that sort of the rationale for remineralizing soil?
That is one of the rationales. There's so many reasons. It's also tremendously important for forests. But as far as soils go and nutrient density, there's an organization that came out of our organization. It's called the Bionutrient Institute, and they're doing a lot of research around nutrient density in terms of biological soil amendments and rock dust and so on. So I think the nutrient density aspect is tremendously important for agriculture. But thinking about forests, if a forest is not healthy, it's giving off CO2 and it's not storing carbon. So we want our forests as healthy as possible. And also, we're tending to be at the end of the interglacial period. And so, forests tend to die off at the end of the interglacial. So we need to strengthen them. And rock dust makes them drought resistant to insects and disease. It changes the pH, so the uptake of nutrients is higher. And so if you think about all the forest fires in California, for example, remineralization would probably do a lot to keep that from happening. And there's actually one researcher there who is saving the California dying oaks, of the California oaks that are dying. And he has a website called Live Oak, something like that, Live Oak. Yeah. And his name is Lee Klinger. So yes, there's so many ramifications because it's something so basic. When I first read this book, The Survival of Civilization, for me, it was just dirt under my feet. And really what I came to understand when I read that book was there is this vast micro universe under our feet, which supports all life. And
if I could ask you more about this thing about saving forests with remineralization, that's the first I've heard of that. How does that theory go?
Just to give you an example, in Europe, research on remineralization already was really taking place in the 1960s with Dr. Peter von Fragstein, and many rock dust companies in Europe were through the decades have been selling rock dust for agriculture. But one study from the University of Munich showed a study in Central Europe that when rock dust was applied to a pine forest, it got 4 times the timber volume over 24 years. And one application of rock dust lasted 60 years. So in other words, if you compare the differences, there was, at 60 years, they needed another application of rock dust. And for example, in the study that Tom did in Panama, all the trees that didn't have the rock dust, none of them survived in the particular trial that he just mentioned. So we would greatly benefit by adding rock dust to soils. And the other thing I want to just mention quickly, because it's really about Canada, is agrogeology. I know that you interviewed Dr. Peter von Fragstein, and agrogeology started in Canada. That is geology in the service of agriculture. And
are you thinking of Peter van Straten?
Peter van Straten, yes. Thank you for correcting me. Yes, Peter van Straten. So that was founded in Canada, but it was specifically in the beginning focused on laterite soils and tropical soils, because in tropical soils, chemical fertilizers get washed away by the intense rainfall, whereas rock dust is heavy. It stays in place. And so Brazil now is the country that has done the most remineralization in the world. They've done research and development for decades. They have remineralized over 5 million hectares, so a lot of soybean production now. And they have sold something like over 1 million tons of rock dust a year. So that is an example of a place, and Peter van Straten has done a lot of work there, because now there are hundreds of students and universities doing their theses and everything. And so he has spent a lot of time in Brazil.
Are they using it for the forests? Or it sounds as if you're talking about farming in Brazil.
Yes, it's for agriculture in Brazil. There is an interest in agroforestry. And agroforestry, there is a wonderful project there at a place called San Semente, SEMENTE, where they use one rock dust application with no outside inputs thereafter, and they grow vegetables, fruits, coffee and cacao in one system, one agroforestry system.
Now, excuse me, I'm really interested in this. Agroforestry in this case is raising food in the forest with under the trees, or raising trees that produce fruits and nuts. Is that what you mean? I mean, the agro I understand, but how's it related to forestry?
Yes, let me just say, for an example, to look at Sitio Semente, I said it incorrectly. And yes, so they're creating a system for raising food that is more like a forest, and using trees. They're planting vegetables underneath. They'll have different stages, and different stages at different times. So there's a wonderful video that you can watch called From Garden to Forest. And if you look at that, it has subtitles in English. It's very inspiring.
Mm-hmm. Okay, fascinating. A whole new topic for us to create talk shows about, I expect. Okay, Tom Vanacore, hi, how are you?
Good, thanks. Great conversation. So I've known Joanna and Tom Gurrow for a lot of years, and we've worked on some projects together. I think it's a great conversation. Yeah, the agroforestry, syntropic farming. There's a bunch of different things you can find if you search around on YouTube. integrating forestry and perennial and annual crops together, especially in the tropics, but it's also being done and being adopted in the northern climates. There's some places where this is happening now, so it's certainly something that's important to look at.
Well, when we talk about Brazil, it's almost always about the cutting down of the rainforest to create beef ranches and things like that.
Right.
But and also farming, but the farm, as I understand it, the soil is so poor that the farming, you only get a few seasons and then you have to move on and then the soil is no good. Now,
Right.
are you saying that there's a way of rehabilitating the areas in which they have depleted, that they've cut down the rainforest for farms
Yeah.
and left a mess behind them? Is
Yeah.
there any way of restoring the quality of the soil?
Right, and the way this is being done now in the tropics is to go into those clear cut areas and stripped out areas and apply a good heavy application of the broad spectrum rock powders at one time, and then start bringing in this technique of, it's a combination of permaculture, forestry management, and annual production, so food crops, tree crops, and using the biomass that's being generated by the forestry, the trees, basically pruning the trees and using the biomass that's being created by the fast growing trees in this environment to recycle biomass and build soils underneath the canopy. So it begins as a sparsely populated tree environment and slowly starts closing in as the canopy closes, and the diversity is changing. It's a type of permaculture. So this is really something that will probably be more and more important in the north, where there are these large swaths of monoculture that could potentially turn into a desert in the absence of intervention. As global warming superheats the atmosphere, there's the potential of drought, or the extremes will make monoculture more and more tenuous. And so this idea of integrating agroforestry, into monoculture technologies in terms of resiliency of growth is one that I think is very, very important to look at as a strategy for survival into the future. And rock minerals can be a base, sort of a foundation. It doesn't even necessarily have to be repeated high doses of rock minerals. You can actually go on one time in preparation for these transitions and go out at heavy applications potentially, and those benefits will last for decades. Or you can integrate the way we're doing it in a smaller applications within whatever farm management is happening. So this is important. I did want to go back to Tom Gros and Joanna's comment about the forest fires and the pH of the atmosphere, the rain that's falling as a result of burning and smoke, and the pH of the oceans, and how this all relates. It's a global system, is both a terrestrial system, land, what's happening on the land, and what's happening in the ocean. And the ocean is probably the biggest driver of climate. Of course, Tom's going to correct me if I'm wrong here, but what we're seeing in the ocean is a precipitous drop in the pH of the ocean, which is really representation of what's happening on land. So the integration of the terrestrial application of rock minerals with abundant growth of healthy plants, and the the environments in the ocean, the maritime environments, restoration are very closely related and need to be looked at together in a whole systems approach to climate mitigation. So I think that's something that conversation should really, we should elaborate a little bit on that because they're intimately connected.
Yeah, especially maybe Tom was already telling me a little about the connection with the coral reefs that he's very concerned with.
Very much so.
Yeah.
Tom?
Tom, do you want to? There are two Toms here, so I have to be careful.
Tom B.
Tom
Tom.
G. Do you want to talk about coral reefs a bit and how it's connected to soil?
Well, let's say this. I mean, the thing is that it's just increasing CO2 in the atmosphere from fossil fuels. It's a major acid in the ocean. So as we increase that, the ocean becomes more acidic, and then the limestone can dissolve. So that's a progressive thing. You know, it's been going on ever since we started putting more CO2 into the atmosphere. The temperature is the really deadly issue for corals, though, not the acidity. The temperature is what's killing them right now. Anyway, I'd just like to come back to what you mentioned about Brazil, because in the 1980s, I actually made the first measurements of greenhouse gas emissions in the Amazon from deforestation. So we're doing a lot of work on that. And it's true that after you burn the forest down, you raise one crop of corn and you burnt out the nutrients forever. You have to abandon the land. And I saw it a great deal myself and what happened with the cattle. But the thing is, that's also where biochar was invented by Amazonian Indians thousands of years ago. That's an indigenous invention. And what they did in the middle of the worst soils in the world is they built up the richest soils in the world, which are the so-called black, dark earths of the Amazon, in Portuguese, a terra preta do índio. And that's what we've just, their knowledge was lost by genocide from European diseases 500 years ago. And so we're slowly relearning that. But actually, it's going to be key to regenerating the Amazon. But you've got to bring in, you can make the carbon from any weedy biomass, which is all they have in a lot of the deforested areas of the Amazon now, because what's coming are weeds. The biodiversity has collapsed, the biomass is collapsing, the ecosystem services have collapsed. But as the other Tom pointed out, you bring in some basalt powder, you can recharge the system to grow much faster, much better. And if you manage it right, to keep recycling that stuff for decade after decade, you know, it's a long-lasting boost. And so we believe the Amazon can be regenerated, but it's very close to the tipping point of turning into a semi-desert. I think in 1968 or so, Robert Goodland at the World Bank wrote a book called Amazon from Green Hell to Red Desert. Okay. And he forecast that this would happen. It is indeed.
Okay, now how would this work? Because for biochar, if you, on the kind of scale that you would need to be cutting down trees to make the biochar, right?
Right,
Now,
but you could do that from the weedy trees that have taken over. There's in these forests where there used to be 500 species of trees, you now have 3 species of useless weeds. That's the stuff to turn into biochar. It was in Brazil, half the land that has been deforested has been abandoned because the weeds are out of control. They can't manage them.
and by weeds, you mean trees.
Well, they're different species. They're trees, they're vines, they're shrubs. They're just things that grow fast, but they don't have useful products or much biomass.
So okay, I'm trying to figure out how you'd work this. Okay, so somebody comes in, they cut down the rainforest, they raise a crop or two, and then they have to go away because they can't grow anything. So then you wait for the place to regenerate a little bit of weeds, and you cut in and you cut those weeds down and make biochar into it and put it on the soil.
Yes, that's correct. That would be the idea, to make biochar, add rock dust, and plant fruit trees to build up the biomass.
And you mix it with rock dust right there, right?
Yes.
Where do you get your rock dust? Is this basalt?
That's an issue. That's an issue because transportation determines the cost. The Amazon is infertile because the sources of basalt are far away, but there are sources in Brazil, all over Brazil, that can be trucked for the same cost as regular fertilizers.
Yeah. So there.
There's a project for the Amazon right now with Dr. Susie Huff Theodoro, and they would be using a dam sediment for remineralizing, I believe. So, and then Brazil has not been energy independent. It very much wants to. It imported all its fertilizers and so on. And they have many sources of rock dust. I mean, very plentiful sources. So.
Hmm.
And that, I think that's an important point to make, is that although basalt rock is a well-balanced, plentiful mineral, there are many sources of the alkaline silicates and other types of placers available regionally, almost in every region, that can be suitable for remineralization. Now, of course, it takes doing some analysis and doing some work with the materials to understand them better. But, the idea that we can take regional or local materials for our mineral and combine that with biomass to produce a biomineral fertilizer, I think is really the key and the way forward to climate mitigation, because it really circumvents the reliance that the forest and especially the agricultural community has on imported fertilizers at distance. In other words, most of the fertilizer that's being produced commercially is only being produced in very few places. As an example, one of the reasons why nitrogen fertilizer became so expensive over the past year or two is because of the war in the Ukraine interrupted the supply of fertilizer coming out of the Balkan regions. And so the entire global economy in fertilizer was disrupted by a war, a proxy war in the Ukraine. And so, global climate mitigation cannot be reliant on a source coming from one area, because it's impossible to do that. We have to work within local resources that are in abundance, using regional sources and regional supplies. And I think this is where remineralization and agroforestry and this sort of biologic management is key. And it's pretty much the largest climate mitigation, I'm saying technology, and sort of putting that in quotes, because it's more of a management strategy, and it's applied technology rather than reliance on an engineered or an engineering approach to climate mitigation.
Thanks. Adele has a question.
Yeah, maybe I have a couple, but the first one is, and pardon my ignorance, but I don't know what is the chemical composition of basalt or any of the other rocks that are proposed for this job. Could you not make them artificially, or what is the energy required to grind up rock to add it? Is another question. And then, of course, the idea of agroforestry is interesting, I think, because there's a lot of trees been planted in deforested places in Canada, British Columbia, other places, but maybe those trees will never grow properly or do anything useful if the soil they're growing in isn't any good anyway. So if you could comment on some of those questions, please.
Let's ask Tom Garreau for change. Okay, Tom Garreau, you want to try replying to Adele? You're muted, I think. I think you're muted. Can't hear you.
I think Tom Vanacore can answer the question better than I can. But I mean, the thing is that look, basically all the elements are found in rocks, except for what's in the air and the water, and what's in the air and the water is only a small fraction of the minerals that are in the rocks, and that's where the minerals, that in most plants and animals and everything, they come from the ground. And so we're talking about maintaining those supplies and keeping them recycled in a way that maximizes the biomass and the biodiversity and the efficiency of recycling. We need all of those together. And what we're doing now with mismanaging the environment is we're wiping everything out. We're destroying all the things we need to survive in the long run.
Thanks. And Tom, yeah, again, what is basalt made of mostly?
Well, there's a lot of different minerals. I mean, I could give you the names, and if you're not a geologist, they wouldn't mean anything to you. But basically, they're different minerals that are compounds of a lot of different metals: aluminum, silicon, oxygen, and calcium. Everything's in there. Everything's in there in little tiny crystals that have slightly different composition, and that's they
Adele,
form.
do you have further questions about this?
Yeah,
Right.
but how do you, I mean, is every basalt the same as every other, or I thought that was just a one kind of rock, but maybe it's a classification of many different kinds of rock. But one of my concerns here is there enough of this rock to grind up? I think there probably is, and what does it cost?
Well, let me jump in here a little bit. First of all, the basalt rock is plentiful across the earth. At one point, I believe that in the geologic history of the earth, the entire planet was essentially covered in this volcanic magma, this primary magma, which was basalt or basalt-like rock. And over the eons, some of it has gone down and others have come up. But the point is, it itself is widely dispersed across the earth. However, there are many types of rock minerals that are similar in that they're alkaline. In other words, they have the base cations, the calcium, magnesium, the sweet minerals, for lack of a better word, that are required for most healthy plants to grow. And they've been crushed, processed, milled, ground, pulverized for forever. I mean, the rock industry is probably the oldest industry on the planet. I mean, from tool making to to milling to extract metals, it's always been done. And in the industrial era, many of these rock types, including the basalt, are actually crushed and pulverized for other purposes besides other than agriculture or forestry. They're used for construction aggregates, they're used for building materials, they're used for cement, concrete. They've been put into cement and concrete, which has then been removed to be salvaged, etc. So there's a legacy stockpiles of these sorts of materials that are in huge abundance in a number of different places adjacent to Canada, in Canada, and have also been associated with other industries. So to begin with, there is plentiful material, rock dust type materials or previously pulverized materials that have been associated with industrial activities and have continued to be produced from industrial activities, including transport and infrastructure, to make available a huge abundance of these materials that would be repurposed or recycled as byproduct to begin with. Eventually, if this really became a climate mitigation initiative globally, it's foreseeable that in the not too distant future, new sources of material would have to be processed. And there's been some very, very good life cycle studies to show that even though it takes energy to pulverize rock minerals to powders, the amount of energy that's being put in, if it's done through a sustainable or renewable type energy systems and not transported over great distance using fossil fuels, on balance, you actually come out on the positive side of the ledger for your thermodynamic accounting. In other words, you still are doing some very, very important work, and it still makes sense from an engineering and thermodynamic standpoint. And the other thing is you're doing you have multiple benefits. You're not just growing a plant, you're actually feeding a population. You're growing building materials, or you're producing medicines and other sorts of things. So it becomes integrated in a whole system approach. It's very easily justifiable if it's done correctly. So I hope that addresses some of your questions.
Yeah, actually, I did want to add one more thing. I mean, that is to say that the supply of minerals from weathering has always been there. It's always been driving life, and we've interfered with that natural release. And that's one reason why our ecosystems are running down. They're running out of what they need to survive. So, remineralization can play a key role. There are clearly challenges in places that are very big and very far away from sources. But the fact is, we're going to have to do this on a huge scale if we want to reverse climate change. I mean, vastly bigger than we're doing now. But the other point I want to make is that the actual weathering, the release of these elements from the rocks, means that the crystals are breaking down, releasing the elements. So that's called weathering. And that's done by CO2. CO2 is consumed and absorbed in the soil in the act of releasing those essential elements. So the weathering itself is also a significant CO2 source. And in nature, it's the way that CO2 is removed from the atmosphere, but it normally takes millions of years. And we have to do it much more quickly now.
Yeah, we're looking at not only the value of enhanced rock weathering for the quality of the soil, but also as a climate mitigation strategy. And I don't have a clear impression. I don't even know whether anybody's made consistent calculations about how much we can count on that methodology as a specific technology to reduce climate change. How much of the world's CO2 can be captured and sequestered this way? Let's just stick to Canada. And I don't know what parts of Canada has soil that needs to be fixed and which parts are just doing fine. But let's assume that all of the parts of Canada that need their farms to be enhanced with rock dust and biochar do so. And with the optimum amount of rock dust, how much difference is that going to make on climate reduction? How much of CO2 can you sequester?
The answer is that if you use the very best technology we have, it could basically solve the problem. But the practices that we're using now are adding to it, because basically almost every commercial farmer is running down the carbon in their soil. They're oxidizing their soil organic matter, they're wiping out their biomass, and they're adding that to the atmosphere. So with conventional practices will take forever. If we use the best practice, it could be done, in principle in a couple decades or generations. But it's not a single solution. The point is we have to apply all the solutions to remove carbon that we have available, increasing biomass, increasing weathering, and all of that. I mean, basically, there's a lot of people proposing single solutions, and none of them are really enough by themselves, but together they all are.
Yes, yeah. I mean, the wonder for this technology is that it's good both for the soil and for the climate issue. But if we just looked at the climate issue alone, how important a methodology would you say that is in comparison with some of the other interventions that have been proposed, such as, we're talking about cloud brightening a while ago. That's one that you might compare it to. How much can you count on it to help reduce climate problems by absorbing CO2 that's already ambient?
Well, remember, the cloud brightening is only a short-term solution, because you have to constantly keep pumping it into the atmosphere because it settles right out in a day or two. Whereas, with CO2, we're talking about something that lasts for many years in the atmosphere. So, in a sense, in the long run, we have to control greenhouse gases. In the short run, we're going to have to use alternative methods to avoid serious overshoot. And that's where we're headed now. We're headed for really a catastrophic situation, in my view.
Well, I'd like to talk a little bit about who is we. That is, who are the decision makers? How do you get this adopted on a wide scale? I just happened to read a newspaper article a couple of days ago, which was paid content. It said McCain Foods is helping potato farmers in New Brunswick to produce better, to do better agricultural practices. Maybe they're putting rock dust in. How do I know? But in any case, who is going to execute these things that are necessary?
Well, it's hard to say. Governments have managed to completely drop the ball. Just had the 27th UN Framework Convention on Climate Change, and they failed for the 27th time in a row to stop global warming. So it's clear they're not listening. When I say we, really, I'm referring to the scientists and the innovators who are out there with their hands in the dirt or in the water, out there trying to make a difference in developing the cutting edge techniques that are going to be needed. I mean, unfortunately, for each farmer who is regenerating their soil, the biomass, and the biodiversity, and they're doing incredible jobs, there are 1,000 or 1,000,000 farmers that are doing the wrong thing. So, public education is going to have to be key, and there's got to be government support for people to do the right thing on a large scale. If they don't do it in time, we're in serious trouble. We really are. I mean, this is based on the
Well,
the
let's
science.
get down to brass tacks. Let's say that Pugwash goes to talk to Justin Trudeau and convinces him to get Canada, the Canadian government, engaged with incentivizing and instructing all farmers in the country to use biochar and rock dust in the right form, the right combination, and to start putting it on their soil now. So now here we have a new project, and you're in charge of designing this system where we're going to teach the farmers, and we're going to pay them a little bit or give them some sort of financial incentive to try it out. And then after a while, we think that maybe they'll see the value of it and want to keep it up because it'll improve their crops.
Yeah.
But now-
Canada probably produces the most wood waste of any country in the world that's left to rot. And if that stuff was turned to biochar, the trimmings and the offcuts and the stuff that they can't use in the lumber industry, that could revolutionize Canadian agriculture. And there are people trying to do that. And Quebec in particular is a friend of mine, very active in that.
Really?
Yeah, so I think for the Canadians, just as Tom was saying, if you present the initiative rather than sort of a mechanistic engineered solution as more of an integrated solution, which is what we've been talking about now for several conversations, where you take forestry, the forestry industry, you take the agriculture industry, you also look for municipal sources of waste, which would be biomass being produced. A tremendous amount of biomass is coming out of waste, green waste, in the places where they're collecting and harvesting any kind of biomass. The combination of these and repurposing of these materials into biomineral fertilizers is the beginning of a regenerative approach to agriculture, forestry, and the environment in general. And that's
Hold on.
that's the
Now you're saying something a little different to me. You're going to take clippings from trees, pruned trees, and the grass that if they mow the lawns and the public parks and things like that, and all of the waste biomass, and you're going to do what to it to produce this?
Well, instead of landfilling it or letting it go to rot in a pile, you're actually converting it to these materials to biomass or biomineral type fertilizers, which
Is
are
this like composting it or making it into biochar, or what are you doing to?
Depending upon where it is, it's all of the above. If it's woody biomass, that's a great distance from any end user. You could convert that material to biocarbon, biochar. You could take the gas that's coming off of that pyrolysis process and actually power the mills with the gas. So there's a cycling of energy and a reduction of loss of energy. You take that biochar, you bring it into contact with minerals, biominerals, and biomass. That's your fundamental, that's the basis for biomineral fertilizers. And so various types of those scenarios can be put in place depending upon where things are being done. For instance, you have a big challenge out on the prairies because, you know, what they're doing is growing grain and then shipping the grain away. Well, there's processing that's happening on the prairies. There's biomass that's being generated, and some of those farms are starting to move towards regenerative type practices, and where they're getting their biomass is either from their from the waste products or the byproducts of the grain industry and grain processing, or they're taking municipal waste, green waste from the cities, and they're converting that into biomass fertilizers. Our suggestion is put the minerals with the biomass fertilizer. So you're, in other words, with the biomass, so you're remineralizing the biomass, and then you're applying that material with
rock dust.
with rock dust, with rock minerals, which is the missing link, because you have to intervene in the carbon cycle somewhere. In
Mhm.
other words, to make the change from where the trajectory that we're going in now, which is, you know, basically climate chaos, to stabilizing the climate, it requires an intervention. It requires a change of energy.
Tom Goro said earlier on that not just that biochar is not all the same thing, that some of it is very different from others, and you don't
Sure.
want to act as if any biochar is equal to every other kind. Okay, now I was
Yeah.
envisioning a thing where we have at the local public park every Saturday, we have a little biochar maker, maybe made out of maybe you know, one of these containers or something. And that they, you know, those metal things that they lift up with your garbage chute things. Well, you could make those into a biochar maker, I think. And then all the people could bring their week's supply of garbage from the gardening and all of that, and the trimmings of their hedge and whatnot, and bring it there, and somebody would be on duty to make it into biochar. But now all of this is the biochar 1 week is going to be composed of certain things, and next week it'll be quite a different set of things. If you made an all-purpose biochar of whatever comes that week, it's going to be a big mix of things. And how will you know where and how to use that?
Well, let me answer a bit of that. I mean, the way that you make it was where we began with this question, is that if you burn the biomass, it goes to CO2 into the atmosphere. So you got to burn it without oxygen. And that's the trick. That's called pyrolysis. And that way you make the full char. Now, the quality of the char depends on what you put into it. You know, leaves and algae are not as good as hardwood, for instance, in terms of the amount of carbon you're going to get out the end. If you do it to really high temperatures, you wind up with nothing but carbon black. Okay,
Right.
everything else is driven off. You do it at low temperatures, you've got the other elements that were in the ash of the plants. And so those will act to release fertilizers too, the low quality stuff. So, you know, a mixture of both kinds is really needed. Now, if you consider what happens when a tree falls down, the leaves are going to rot and decompose and turn to CO2 within a year. Depends on where you are. Where I come from, a lot less, but, you know, depends in the tropics. But at any rate, so it doesn't last very long. If you turn it into biochar, how long it lasts depends on the quality. The low-grade stuff might last years, tens of years, hundreds of years, thousands of years. The high-quality stuff actually lasts hundreds of millions of years. It's quite amazing. You can find the ash from forest fires that are 350 million years old, where you can see every plant cell when you look at the ash in the microscope. These are just things that have been carbonized in place. So in fact, you see, that's a form of carbon that practically lasts forever. The reason you need the rock powder with it is because the high surface area that it provides holds onto the water and the nutrients that get released by weathering from the rock powder. So they're ideal complements. That's the idea.
Okay, now we're not going, if we went out and we say, farmers, just take some biochar and some rock dust and put it together and put it on your soil, you're not going to do any harm. we're not sure that you know exactly the right mix to use.
Yeah. And a
But
little
it's-
compost.
Is it going to do, is it going to do any damage to anybody with that kind of all-purpose in poorly defined set of instructions on what to use and what combinations and stuff? Because if we say that every farmer in Canada has to be taught individually what his particular field needs, and maybe he has fields that have different needs, and each field needs to be assayed and tested all the time, and then the mixture of biochar and rot dust that you put together has to be finally calibrated to meet their demands, that's not going to work too well. But if we just say, in general, farmer, go get yourself some of this stuff and put it together and try it out. It's going to work. It's going to do something for you, and it won't hurt anything. Is that fair enough? Or will we hurt
Well,
somebody?
Well, I think you're starting to talk about a couple of different things, and you're not really talking about the way this would be done if you're actually wanting to ramp up and scale up into a climate mitigation initiative. You would have to actually have in place the volume capacities to address the proper management and best management practices on this farm, which you're going to have to do anyway in order to make improved agricultural practices a reality. And the farmers are going there already. I mean, most of the farmers are already starting to see, if they haven't already, that something else is needed, if not for anything else, then to avoid the astronomical costs of synthetic fertilizer. So something else is going to be done. And our suggestion is biologic management, and the use of these materials is an answer. And so to try to micromanage every farm, to try to micromanage, 150 sources of materials in 150 different ways, that, as you said, that's not going to work. But it will work if you take advantage of the logistics and infrastructure that's already in place to handle large quantities of materials, and in some cases convert some of those to biologic management, and in other cases build new. Then all of a sudden you have the infrastructure to integrate fully with what is already being done, because they're already taking soil tests, they're already spreading materials on their fields, they're already handling huge quantities of biomass. And rather than, in the case of the biomass, rather than landfilling or just piling it up and let it rot, you're actually saying, well, that's a good source of feedstock for biomineral fertilizer, remineralized fertilizers, that has a climate benefit and a benefit to humans because of the nutrient density, so forth. So it's subtle, but it's effective because we're working with what's already there.
Okay, well, we're on our way. We just don't know how to get there quite yet, but yeah, I'll get back to you because all of you have been very, very helpful today. And stimulated a whole bunch of new questions in my own mind. Anybody have any urgent thing you want to say before we say goodbye?
Well, I just want to say that people can experiment, and half of the ones who experiment with biochar use raw biochar and get negative results because they don't mix it with rock powder and a little compost. That's key. So they'd benefit. One thing I would say is that many people know this by experience, because all traditional cultures that move around go back to their old campsites because they're more fertile because of the ash mixed in them. That's how the Amazonian Indians learned this in the ancient times in the first place, So there's a lot of common knowledge that goes. And the other thing is that in every place in the world where forests were burned, cut down and burned to make agriculture and pasture, about half the carbon in the soil is biochar from the ancient fires that they burned. So the Ukraine, the black soils of the Ukraine that are the richest soils in the world, are the remnants of a huge forest that was burned down. It's half the carbon in it is biochar.
My goodness, my goodness. Okay, well, I learn something new every time I talk to you guys. Thank you very, very much. It's been fun. And I'll probably get back to you because I'm not through. Okay.
Thank you, Amanda.
Okay, thank you all.